Welcome back. So now we're going to be doing a little more graphing of quadratic functions. But first, let's review finding x-intercepts. Right, so when we're finding an x-intercept, we're going to set the function equal to 0 and solve. In standard form, you can factor, and you should pull out the greatest common factor first if possible. And it's possible so long as there is one. There's not always a greatest common factor. But so long as it's factorable, we can always use factor by grouping. If you can't use factor by grouping because the equation doesn't factor, then you can use completing the square, the quadratic formula, or you can take a square root of both sides. And you can do that if there is no x term. So those are some options if you can't factor. In vertex form, you just want to isolate the squared term, the something squared in parentheses, and take a square root of both sides. Don't forget the plus or minus for the constant terms. And if it's in an intercept form, well, that's the easiest form to find your x-intercepts. Just isolate your factors and set each factor equal to 0. Okay? That's why it's called intercept form. It tells you the x-intercepts. So that's the easiest method to find, or the easiest format to find your x-intercepts. Let's graph this function. This function is in vertex form. And I will tell you, since I have already figured this out on this particular one, we're going to want a scale where each box is 2. All right, so on the x it'll be 2, on the y it'll be 2. Otherwise, we're going to have trouble fitting all of our points in. So let's find our axis of symmetry first. I'm just going to move this out of my way. All right, so this is vertex form. I should write that in. And vertex form is the easiest form to find the vertex and axis of symmetry. That's why it's called vertex form. So remember, vertex form is y equals a times x minus h. I'm already thinking of the vertex. X minus h squared plus k. Our vertex is hk. All right, so this value right there is going to give us our vertex and our axis of symmetry. Let's find the axis of symmetry first. Now that value is not 5, right, because it's x minus h. Right? So that negative goes with the equation. So that means that that's really x minus a negative 5. So our axis of symmetry is going to be at x equals negative 5. We can graph our axis of symmetry. All right, so each one of these boxes is 2, so that's 2, that's 4, and right there is 5. All right, so we can, oops, my line's too high up in the air. So now we can write x equals negative 5 for our axis of symmetry. For our vertex, right, we're going to need the negative 5. And then we just have to look to see what's added into our function when it's in vertex form. So the y-coordinate of the vertex is 4. Right? So vertex is easy when it's in vertex form. And so let's graph that. Oops, I almost forgot. Our scale is 2. So it won't go there. It'll go right here. So that would be 4. So let's write that value in. This is the value, negative 5, 4. Now let's find our y-intercept. I'm going to switch colors here. All right, so for our y-intercept, we just plug in 0 for the x. Y equals negative 0 plus 5 squared plus 4. So this is going to be negative 5 squared plus 4. So that's going to be a negative 25 plus 4. So our y-intercept is going to be negative 21. And now you can see why I changed the scale. All right, so our y-intercept is 0, negative 21. Let's graph that point. I guess I'll just keep writing in blue for the graph. So let's see. We're going to have to go down 10.5 spaces. So let's see. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, right here. So because of that point, we had to change it. So I don't change the scale unless it's, it's going to be more than 10 or 12. Then I change the scale, so every box is 2. Unless we have a really big graph. All right, x-intercepts, just plug in and say, so for the y-intercept, you plug in 0 for x. For the x-intercept, you plug in 0 for y. All right, so let's find the x-intercept. So we have 0 equals negative 0, x, getting carried away writing zeros, x plus 5 squared plus 4. All right, so now we want to isolate our something squared. This is our square term. That's our something squared. So now let's subtract 4 from both sides. We have negative 4 equals negative x plus 5 squared. Our something squared is not isolated yet. We've got to divide everything by negative 1. So now we have 4 equals x plus 5 squared. Now our something squared is isolated. We can take a square root. Don't forget plus or minus for the constant. And then we'll take the square root on this side. So the square root of 4 is 2. So we have plus or minus 2. Square and square root cancel. So this is going to be x plus 5. And now we just got to isolate x. So we're going to subtract 5 from both sides. So this is negative 5 plus 2 equals x. And negative 5 minus 2 equals x. Don't ever leave your answer there as negative 5 plus or minus 2. Okay? We need to split that up because these are numbers we can combine and simplify. So this is going to be negative 3, which means one x-intercept is negative 3, 0. We always want to write our intercepts as points. And then negative 7 is what we get when we add those together. So negative 7, 0, that's the other x-intercept. So let's write that in. So we have negative 3, 0, and negative 7, 0. All right, and let's put that on the graph, and we're almost done. All right, so that's going to be right here. That would be negative 3. Let's write that in. Negative 3, 0. And then on the other side, so this is 6, right? So right here is going to be 7. So that's going to be negative 7, 0. Let's graph one more point because we can use symmetry. So if I've got a point 2.5 to the right, I've got to have another point here. Well, technically this is 5 to the right, but it's 2.5 boxes. So we have to have another point right here. That's 2.5 boxes to the left. All right, so the line there is at negative 5. We've technically moved over 5 spaces, right, because each one of our boxes is worth 2. So this is the point negative 10, negative 21. Take advantage of symmetry. It'll help you draw better graphs. So now we'll just play connect the dots. There we go. So there's our function graphed. Let's just add in domain and range. And I'll change colors one more time. Let's do purple. All right. Always, 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 your domain is all real numbers for quadratic functions. Actually, all polynomial functions. And we're going to learn some more polynomial functions coming soon. Because there's nothing, no number at all, no real number you can't multiply, square, multiply by a number, square, add a number to. Right? Our domain is going to be all real numbers. Right? It doesn't look like it's going out very far right now, but remember, as we go, as x is going to go all the way to infinity, right? It's going to keep getting wider and wider on both sides, right? So eventually, it's just going to keep growing and growing and growing in the negative direction, right, on the y, and in both directions on the x. Our range, that's the one that has the restriction because our function turned around. Right? Since it's pointing, the arrows are pointing down, it's going to keep going to negative infinity, but it's going to stop at 4. And it does go through 4 because it's our vertex, so we're going to use a bracket. And that's all there is to graphing our quadratic function here. Graphing y equals negative x plus 5 all squared plus 4. All right, let's graph a couple more. So we did one in vertex form. Now we have one in intercept form. All right, so this one I gave myself 2 spaces, although quite honestly I could have used 1 page. All right, and we never did this. we never determined whether the graph opened up or down. Although we did graph it correctly, we should do that. It's always very helpful. Notice that our A here is -1. So our graph is going to open down. This graph is concave down. Concave down. Whoops. I accidentally hit the little box. That's my recording box. That's why there we go. Thing went all crazy. Let's move our comma over. Oops. Maybe I can't. Oops. Oh no. Here we go. Come. Well, I don't think that comma wants to move over. There we go. And my poor word. It got all broken up. There we go. Concave down. So long to write a word. All right, so this one is also concave down because our A is -1/2. There's no B or C when our equation is not in standard form, but there's always an A, and it's that coefficient. All right, so A is -1/2, so therefore the graph is concave down. Right, because -1/2 is less than 0. Let's find our axis of symmetry. Our P and Q, those are just our x-intercepts. Right? Let's find our x-intercepts and then go back and find the axis of symmetry. I think that might be easier for some students. And I'm just kind of moving everything up here because I have hardly any space at the bottom there to find my x-intercepts. There we go. All right. So remember, you plug in 0 and for the f of x here. And so if we were to multiply everything by -2, that would eliminate that -1/2, right? Because the negative times a negative is 1, and half of 2 is 1. So now we would have just a coefficient of 1. And we'll do this to the other side, because if we do it to one side, we've got to do it to the other side. Well, 0 times -2, that's 0. So we have 0 equals x times x minus 8. And it always works out that way, that when you multiply by whatever a is, or divide by a, depending if it's not a fraction, to both sides, you're always just left with your factors. So if you just set each factor equal to 0, you'll have your x-intercepts when it's in intercept form. So if x is equal to 0, well, x is equal to 0, and that's one of our x-intercepts. And if x minus 8 is equal to 0, then x is equal to 8. We'd add 8 to both sides, and eventually the rest of that word, there we go, will come up. So 8, 0 is our other x-intercept. So now that we know our x-intercepts, to find our axis of symmetry, that P and Q, those are our x-intercepts. We can just add those and divide by 2. All right, so essentially, this here, whatever we add to, so let me expand this out a little bit just to make sure it's clear to everybody, and I'll write it up here. So on our equation, we could write that plain old x there as x minus 0. That may have fooled you. You may have not thought that was intercept form because there's no p in there. Right? That's not needed. And then this would be x minus 8. So right here, these are your x-intercepts, and those are your p and q. So to find our axis of symmetry, we're just going to add 0 plus 8 and divide by 2. So whether you find your x-intercepts and remember to add those and divide by 2, right? Or you remember the format, x minus p and x minus q, either will work to get your axis of symmetry and your vertex. So now we have 8 divided by 2, well that's 4. So that means our axis of symmetry is 4, and it's also the x-coordinate of our vertex. To find the y-coordinate, you just plug in 4 for x. So we have f of 4 equals negative 1/2 times 4 times 4 minus 8. Right, so I'm going to kind of move over here. That would be negative 1/2 times 4 times negative 4. I'm going to multiply the 4 and negative 4 first. So 4 times negative 4, that's negative 16. And negative 1/2 times negative 16 is going to be a positive 8. So the y-coordinate of our vertex is 4, 8. Last thing we need is the y-intercept. Can you figure out what the y-intercept might be? Let's find out if you're right. Think in your head what the y-intercept is. So to find the y-intercept, we plug in 0 for x. So we have f of 0 equals negative 1/2 times 0 times 0 minus 8. Well, I'm not going to even bother to add or subtract negative 8 from 0 or 8 from 0, right? Because I'm multiplying by 0. 1/2 times 0 times negative 8 is 0. And we should have guessed our y-intercept was going to be 0 because we have the point 0, 0. It's 0 on the x and 0 on the y. So our y-intercept also 0, 0. If one of your x-intercepts is 0, 0, so is your y-intercept. Now let's graph our points. I hope you got your notes all filled in. Of course, if you didn't, just pause me, rewind me. All right. So our axis of symmetry was x equals 4. And remember, this was concave down. I did 2 concave down in this one. In this podcast so far, our vertex, right? Remember we added 8 and 0 divided by 2. That gave us the 4. And if we plugged 4 in, we got the point 4, 8. That was our vertex. The y-intercept, that was 0, 0, which was also one of our x-intercepts. And then the other one was 8, 0. Let's graph our points. And let's move our axis of symmetry in the right spot. This time I have a little line for an axis of symmetry. This one is at x equals 4. And we don't have to change the scale. 1, 2, 3, 4. Because we see all our points, and we can graph all of those on this graph. All right, so this is our axis of symmetry. Let's write that in. X equals 4. And our vertex, 2, 3, 4, 5, 6, 7, 8. We just count up to 8, so that's the point 4, 8. Our x-intercepts and y-intercept, we got 0, 0. And we have 8, 0. 2, 3, 4 right there is going to be 8, 0. Now we only have 3 points, but that's probably enough. All right, if you want one more point so that you have another point that's past the x-axis, we could just plug in a value. I'd plug in negative 1. Right? I want to stay close to one of my x-intercepts, and so that would be either negative 1 or 9. And either one is going to give you the exact same number. All right, so, and we'll take, I guess, we'll take the negative 1. All right, so f of negative 1 equals negative 1/2, negative 1, and negative 1 minus 8. So that would be, I should have chose probably negative 2, because I'm going to end up with an odd number here for, oh no I'm not, oh yes I am. I'm going to end up with an odd number over here, and so then we have to take half of an odd number, and so we're going to have to figure out a halfway point. So instead of using negative 1, I'm going to use negative 2. Actually, I'm going to use 10. I'll get the same number for negative 2 and 10 because they're the same distance away from that axis, of symmetry. I don't know how that happened. I wasn't even touching the board. Although it is the thunderstorm outside. Maybe that's upsetting the board. It's scared. All right, so we have negative 1/2 times 10 minus 8. And so that would be negative 1/2 times 10 times 2. I like this number better because I don't have to graph a half. I can get a nice integer, and it's still going to fit in here. All right, so half of 10 is 5. 5 times 2 is 10. And actually negative 10, right, because there's a negative there. So my bonus point is the point 10, negative 10. And we're going to get another one on the other side. So got 10, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I only have 3 points, I usually like to get another point. So I'm not kind of guessing the rest of the shape of my graph here. And then if I have 1, 2, 3, 4, 5, 6 this direction, I have to have 1, 2, 3, 4, 5, 6 this direction. So our other bonus point would be negative 2, negative 10. So I would have gotten the same thing whether I plugged in negative 2 or I plugged in 10, right? Because negative 2 minus 8 would have given me the negative there. Right? And then I would have had another negative 2 where x is, then I'd have 3 negatives, and so it would still be negative. And so now I'm going to connect. Oh, look at those points. Nice big graph. There we go. Look how pretty. All right, domain and range. I hope you're seeing the pattern with the domain. All right, all real numbers, negative infinity to infinity. Range, our parabola is pointing down. All right, so it's going to keep heading forever and ever and ever, and so it'll decrease without bounds, but it has a stopping point, a turning point, right? There's a point where my graph isn't going to get any higher, and our maximum value here is 8. So let's kind of just review maximum and minimum while we're here. All right, so 8 is the maximum for my function. If they write it as a point, they might say 4, 8. Right? So 4 is where it occurs. So in parentheses, I'm just going to put 4, 8. So it occurs when x is 4. And what is the maximum? 8. That's the largest our function is going to get. And notice it's the y-coordinate of the vertex. So if we look back at this particular graph, this one back here, the maximum value for this graph is going to be when at 4. 4 is our maximum, and it occurs when x is negative 5. All right, so here our vertex is a maximum. That's right, vertex is. And you should add this to your notes as well. Vertex is a maximum because the parabola is concave down. All right, so our vertex is at a high point. And the same thing over here, the parabola, oops, one more, the parabola over here, the vertex is a maximum because your parabola is concave down. I think I have just one more to graph. No, I have one more or 2 more? Well, we'll find out. No, it is one more. It is one more. It's this one. All right, so we want to graph the function f of x equals x squared minus 2x plus 10. Let's determine whether the graph opens upward or downward. Right, so here, got to have 1 that opens upwards. A is 1. Right, it's the coefficient in front of x squared. Therefore, our graph is concave up. Let's find the axis of symmetry. So now we do have to use our formula because our equation is in, let's write that in, standard form. I forgot to write it in on the last one. I'll keep forgetting. I wanted to keep reminding you of the format of each of our equations. I kind of remember it when I get to the next graph for some reason. So this one was intercept form. Let's squeeze that in. Whoops, what the heck? I guess I was too close to the top and I hit change the page. So now we know my board does not like it if I write too close to the top. So we will write it, we'll move that down, and I'll write teeny tiny, not to upset the board. Intercept form, all right? So this one is intercept form. All right, so it's all factored out like this, it's intercept form. And so this one, our last one here, is going to be standard form. All right, so since it's standard form, we're going to use our formula for our axis of symmetry. All right, so x is equal to negative b divided by 2a. I wrote down our A is 1, and our B is -2. And our C is 10. Let's write that in there. All right, so axis of symmetry is going to be x equals a -2 divided by 2 times 1. That's going to give us a +2 divided by 2, so our axis of symmetry is 1. To find the vertex, we may as well just plug in. It's not that difficult to plug 1 in. Just a little old lowly 1. There we go. So we have f of 1 equals 1 squared minus 2 times 1 plus 10. So that's going to be 1 minus 2 plus 10. 1 minus 2 is a -1. -1 plus 10 is 9. Right? So our vertex is the point 1, 9. Our y-intercept is the easiest thing of all. And when it's in standard form, it's going to be your constant, because if you plug in 0 for x squared and 0 for the x and the -2x, the only thing left is 10. So our y-intercept is 0, 10. So that's the easy thing for standard form, is the y-intercept. All right, so 2 out of 3 are done. Let's find our x-intercepts. All right, so we have a is 1, b is -2, c is 10. All right, so we're going to do a times c. All right, multiply, so 1 times 10 is 10, multiplies to give us 10, adds to give us our b term of -2. Well, factors of 10. Either they're, if it's got to multiply to be a positive, they're either both positive or both negative. All right, so let's try our factors here, and we see a negative, right? So we have a -b we're adding up to, so let's think it's got to be both negative. Well, 5 times -2 is 10, and -10 times -1 is 10. Those are the only factors for 10. But -5 times -2 is not equal to -2. That's equal to -7. That doesn't work out. And -10 plus -1 is -11. That's not -2. How are we going to factor this? Nothing seems to be equal to -2. There are no more factors for 10. Let's try our discriminant and see what's going on here. All right, so let's plug in the values. So we have -2 squared minus 4 times 1 times 10. That's going to be 4 minus 40. And that's equal to -36. Our discriminant is negative. And we know that if our discriminant is less than 0, we don't have any rational solutions. We have a complex root. So you can't graph a complex number on a real number plane, coordinate plane. You also can't factor. Right, so since our discriminant is less than 0, we have 2 complex solutions. All right, 2 complex solutions. So we have no real solutions. We have no x-intercepts, right? Because these are complex solutions. Now we have solutions. You can't tell me that we can't solve. Boy, that's some serious thunder. But what we can't do is we can't factor, and even if we use another solving technique, like completing the square or quadratic formula, we're not going to get a real number. And since it's not a real number, it's a complex root, we're not going to have any x-intercepts. So, did I give us space to solve, or should I solve over here? Yeah, let's just solve over here because it's good practice. Good practice for us. All right, so let's find out what the solutions are, but we're not going to be graphing them. And actually, this is a really nice one. Well, first of all, I want you to see, yeah, they really are complex. Our discriminant says so, but I want to show you they really are complex. And this is actually a nice one for completing the square. All right, so we have x squared minus 2x plus 10 equals 0. we're going to subtract the 10 from both sides. So that's going to be x squared minus 2x equals negative 10. If you're one to forget when you're moving it to the other side that you're really subtracting and you need to change the sign, then write in minus 10. You know, give yourself a little minus 10. So you remember that's going to be negative. All right, I left myself a space here, right, so that I could just add my special number. And my special number is buzz, 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 b divided by 2 squared. So that would be negative 2 divided by 2 squared. Well, that's all just kind of stuck like that. That looks like a weird drawing. Try that again. Negative 2 divided by 2 squared. It's not much better, but I think it's good enough. All right, so x squared minus 2x plus 1 equals negative 10 plus 1. Now we can factor using completing the square. So now we have x, and it's going to be the same sign, minus, as our b term there, and it's just going to be half of b. Matter of fact, it's going to be this number right here that I squared. Negative 2 divided by 2, that's negative 1. So this is x minus 1 times x minus 1. If you multiply something by itself, then it's x minus 1 squared. On the other side, we have a negative 9. Now we can take the square root of both sides. So look how little space this takes us. So if you are thinking when you're solving, and you leave a little extra space to write that b divided by 2 squared, it'll take you less steps. Right? And it's not like we're skipping steps. We just did them together. Right? First, we moved the negative 10. We left a space, so we could just plop that b divided by 2 squared right in there. So we have x minus 1, square root of x minus 1 squared equals plus or minus the square root of negative 9. Square and square root cancel, so that's an x minus 1 equals, and we have a perfect square. Square root of negative 9 is 3i. So now you can see that's complex. So if we add 1, we'll have our solution. So here's our solution. I should have really given myself just a tad more room. Let me see if I can give myself just a teeny weensy bit more room. Whoops. What I was trying to do is that. Grab everybody. There we go. And so we're going to add 1 to both sides. So x equals 1 plus or minus 3i. All right, so this is a complex solution. All right, so when you have a complex solution, there are no x-intercepts. There is a solution. You can solve it. So don't ever say that a quadratic function is not solvable or there's no solutions. There's always solutions. There might not be x-intercepts. It has to be real numbers to be x-intercepts. It can be irrational, can have a radical, but it can't be complex. All right, let's finish this up because we're basically done. All right, our axis of symmetry, if you remember way back before we started finding our complex solutions there, it was 1, 1, 9. And so we only had 2 points here, 2 little itty bitty points. We're going to have to get some more points. All right, so our axis of symmetry was x equals 1. The vertex was the point 1, 9. Right, we plugged 1 in and we got 9. And then our y-intercept is 0, 10. And there are no x-intercepts, right, because we have 2 complex solutions. Let's graph what we have, and then we'll plug in something, a point, to give us another point, hopefully. Or maybe we can use some symmetry. I don't know if we're going to be able to plug in too many points because we're right at the top of this graph. All right, so 1, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're not going to have too much space left. I don't think we can plug anything else in here. We're going to be off our graph. And now I could change the scale, but I'm not going to. All right, and so we have 0, 10. So that's our y-intercept. Well, we can get one more point with symmetry. This would be the point 2, 10. And I say, even though it's a teeny weeny graph, we're going to take it. all right, rather than change the scale. All right, we have enough of a graph there, I think. It's just teeny tiny. Our domain, even if your solutions are complex, your domain is still infinity to infinity. The range, right, we look to our vertex. Right, so now 9 is not our high value, it's our low value. And it's reaching to the sky, so it's going to keep going to infinity. All right, so now our vertex is a minimum. And our minimum value is 9. And that's the point, 1, 9. So our minimum is 9. When does it occur? When x is 1. And I think this might be my last slide for this particular podcast. Thanks for watching, reviewing, graphing quadratic functions. In the next podcast, we are going to look at writing the equations for quadratic functions. Thanks for watching.